Alright, this is exercise video number 20, and for my exercise today I ran 11 miles outside with a pace of 10 minutes and 30 seconds per mile. So that was pretty intense. As you can see, I've got some ice on my shins right now because I'm pretty sure I have shin splints, but yeah. So during that run, obviously oxygen had to be delivered to my tissues. In order to allow for oxidative phosphorylation to occur, you need that oxygen delivered to that third proton pump in the electron transport chain. And so in order for that to happen, I have to have oxygen in my blood, and that has to be delivered to my tissues. And so what happens is, in the heart, blood is received through the superior and inferior vena cava into the right atrium, and then that blood is then pumped into the right ventricle, and 70% of that blood is filling passively into the right ventricle, but that other 30% is from contraction. And so what happens is you have the sinoatrial node, which is in your right atrium, and so that node is it spontaneously depolarizes. And so what happens is when that happens, you've got intercalated discs in your heart, and so signals are sent from cell to cell. And so when that sinoatrial node depolarizes spontaneously, it allows for the entire upper portion of the heart to contract at once. So both atria contract at the same time. And then that blood, the rest of the 30% is pumped into the right ventricle. However, what happens is that depolarization from the sinoatrial node eventually reaches the atrioventricular node. And whenever it reaches the atrioventricular node, there's a slight delay, and that is when the right ventricle is filling passively with that 70% of blood, and that is what we call diastole. And then the contraction of the right atria for the rest of the blood to enter the right ventricle is what we call systole. And so whenever that signal reaches the atrioventricular node, like I said, there's that little delay, and then after that delay you get that signal sent into the interventricular septum, and so it goes to the HEMS, and then it goes into the Purkinje fibers, and that is on the thick muscular part of the ventricles, which allows for those ventricles to contract in order for blood to be transported from the ventricles into either the aorta if it's coming from the left ventricle, or to the pulmonary vein or arteries if it is the right ventricle. But anyways, so whenever blood leaves the right atria, like I said, that 30% contracts, goes into the right ventricle, and then it leaves the right ventricle via the pulmonary arteries. Then that blood goes to your lungs, picks up oxygen, drops off CO2, and then after that, blood enters the left atria via the pulmonary veins, and it is oxygenated at that point, and then goes 70% into the left ventricle, goes in passively, and then the other 30% is from that contraction from what I explained before, and then from the left ventricle goes out through the aorta, and then that aorta branches off into arterioles, and then those arterioles go into your capillary bed, and in the capillary bed you get gas exchange, and so that is when oxygen is dropped off into your tissues in order for all these things to occur, for oxidative phosphorylation, and also that is where blood glucose is picked up to be delivered to your muscles to be stored, and that is how we allow for glycolysis to happen. And then after the capillaries, you get that blood and it goes to the venules, and then from the venules goes to the veins, and then eventually to the superior and inferior vena cava and back into that right atrium, and the whole thing just happens again.